June 12, 1944. The air smelled of wet earth, diesel, and smoke. The fields of Normandy, once quiet and green, were now a patchwork of wrecked tanks and churned soil. The hedgerows stood tall, ancient walls of tangled roots, stone, and mud that had defied centuries of weather and now defied the Allied advance. In the gray morning light, Corporal Curtis Cullen wiped grime from his hands and stared at a Sherman tank half buried in the bank of a hedgerow. Its belly armor was split open, its treads twisted, its crew already gone. He crouched beside the wreck and traced the gouge where the German shell had punched through. The same story, over and over again. Tanks would hit a hedge, climb, tilt upward, and expose the thin plate under their hull. One German gunner waiting on the far side was all it took. One shot, one explosion, one crew lost. The Allies weren't being stopped by superior German tanks. They were being stopped by the landscape itself. For 6 days after D-Day, the hedgerows of Normandy had turned the invasion into a crawl. The generals called it tactical friction. The men on the ground called it murder. Every hedge hid an ambush. Every field became a killing box. Cullen wasn't an engineer or an officer. Before the war, he'd fixed carburetors in New Jersey garages and welded broken farm trucks. But he knew machines. He understood how force moved through metal, how pressure could be redirected, and how leverage could make the impossible possible. Watching another tank crew fail to crest a hedge and die for it, he saw something that others had missed. The problem wasn't the hedge. The problem was the angle. Tanks were trying to go over when they should have been going through. He pulled a small, grease-stained notebook from his pocket and started sketching. Not a detailed blueprint, just rough lines and arrows, a shape taking form in his mind. 4 angled steel prongs extending forward from a Sherman's nose, low enough to bite into the base of the hedge. They'd slice through dirt and roots, not climb them. The tank wouldn't tilt. The armor would stay forward. The Germans couldn't hit what they couldn't see. By nightfall, he had pages of sketches. His crewmates laughed when they saw him drawing under a lantern. "Kurt's building a tank with horns," one joked. But he didn't care. Somewhere in the chaos of his thoughts was an answer. The next morning, Cullen walked straight into his commanding officer's tent. Captain Morrison was poring over maps, muttering about stalled advances. Cullen saluted, hesitated, then held up his notebook. "Sir, I think I can get our tanks through those hedges." Morrison didn't look up at first. "You and every engineer in France, Corporal. What makes you different?" Cullen swallowed. "I don't want to climb over them, sir. I want to cut through them." That got Morrison's attention. He raised an eyebrow. "Cut through? With what wishful thinking?" "With scrap metal," Cullen said simply. "We've got beaches full of German tank traps. They're made of hardened steel. If we cut them apart and weld the pieces to a Sherman's front, it'll punch through the hedge instead of riding over it. The armor stays pointed forward. The belly stays protected." Morrison leaned back, studying him. "You're talking about welding experimental equipment onto an active tank in combat conditions?" "Yes, sir. Give me 48 hours and 1 damaged Sherman. If it doesn't work, we lose a tank we already can't use. If it works, we can start moving again." The captain tapped his pen against the map. The logic was simple, the risk enormous. But desperate times favored desperate ideas. Finally, he sighed. "You've got 48 hours. If it kills anyone, I'll make sure your name is remembered for all the wrong reasons." That was all the permission Cullen needed. He rounded up a crew of volunteers, men who didn't mind welding in a war zone. They scavenged the beaches for the twisted remains of German Czech hedgehogs, those 3-legged steel obstacles meant to stop landing craft. Now they'd serve a new purpose. Sparks flew through the night as Cullen's team cut the obstacles apart, measured, and re-welded them into crude prongs. Each piece was about 4 feet long, sharpened at the end, and thick enough to survive an impact. They worked under flickering lanterns and the sound of distant artillery. The beach wind carried smoke and the faint smell of salt and cordite. By dawn, they had 4 steel tusks welded to the front of a Sherman's hull. The tank looked monstrous, part machine, part animal. Someone joked that it looked like a rhinoceros in armor. The name stuck. But even as fatigue blurred his eyes, Cullen double-checked every weld. The angles mattered. Too steep, and the tank would dig into the dirt and stall. Too shallow, and it would climb instead of cut. He measured with string, eyeballed distances, then re-welded the left prong an inch lower. Precision mattered. Lives would depend on it. When the sun rose on the second morning, Captain Morrison arrived to inspect the work. He circled the tank, his face unreadable. "It's ugly," he finally said. "Yes, sir," Cullen replied. "But so is this war." "Tomorrow morning," Morrison said, "we test it. If it fails, you're back to fixing jeeps." Cullen barely slept that night. He lay on a cot staring at the tent's canvas roof, running through every possible failure. What if the welds cracked on impact? What if the prongs dug too deep? What if the whole contraption folded under pressure? His stomach turned at the thought. But another image haunted him more: the burning wrecks, the screams of trapped crews. If this worked, they'd stop dying like that. At dawn, a crowd gathered near a massive hedgerow chosen for the trial. The field was damp with mist, and the air buzzed with expectation. Officers stood beside jeeps, soldiers whispered bets. Cullen stood off to the side, hands clenched, as the Rhino one rumbled to life. Its engine roared, black smoke curling into the sky. The tank rolled forward, treads grinding over the soft earth, steel tusks gleaming with dew. The hedgerow loomed ahead, 12 feet high, centuries old, roots thick as a man's arm. Cullen's pulse hammered in his throat. At 50 yards, Captain Morrison raised his arm, then dropped it. The driver gunned the engine. The Sherman surged forward, 30 tons of steel charging straight at the hedge. The sound was a physical thing, an earth-shaking roar that swallowed every other noise. The moment of impact came with a thunderous crack. Dirt and stone exploded into the air. The tank jolted, almost stopping. For an agonizing few seconds it seemed to be stuck, engine straining, tread spinning. Cullen held his breath. Then the front dipped, the tusks bit deep, and the Sherman began to crawl forward again, slowly at first, then with unstoppable momentum. Roots snapped like gunfire. Clods of earth tumbled aside. The tank kept its nose down, never exposing its underside. And then, with a final heave, the Rhino burst through the other side, breaking into the next field in a spray of mud. The silence that followed was absolute. Then, as realization spread, the watching soldiers erupted into cheers. Helmets went into the air. Someone shouted, "It worked!" Morrison turned to Cullen, eyes wide. "Well, Sergeant," he said with a grin that broke through days of exhaustion, "it looks like you just taught a tank to eat." Cullen could only nod. The idea that had started as a greasy sketch on a ration box had just changed the course of the Normandy campaign. The first test had been controlled. The second would be merciless. Cullen had insisted the modification prove itself not just before officers and curious soldiers, but under the chaos of real battle. If the hedgerow cutter failed where bullets sang and shells fell, then it was little more than a curiosity. If it held, then the war itself might bend around it. At dawn the following day, rain stitched gray across the fields. Orders came down. A nearby German strongpoint had stalled an entire battalion. Machine gun nests and concealed anti-tank teams had turned its approach into a slaughter. The plan was blunt and simple. Lead with the modified Sherman, punch through the hedgerows, and let infantry pour through the breach. The Rhino would be a wedge, a moving gapmaker in a landscape built for defense. Kurt Cullen climbed into the command cupola and felt every vibration of the engine under his palms. The crew moved with a quiet, practiced urgency. Corporal Mitchell slid into the driver's seat. Sergeant Harrison manned the main gun. Private Chin checked the loader's ammo. They were volunteers, tough, a little reckless, and willing to bet their lives on an idea scratched in grease. Cullen felt a fierce gratitude for them. They trusted a mechanic's gut more than the latest field manual. They rolled toward the target, the world narrowed to engine, sight lines, and the hedgerow ahead. The first obstacle snapped under the prongs as it had in the test. They kept going, 1, 2, 3 breaches, until radio chatter reported German small arms fire flaring from the far side of the field. Then came the real threat, a Panther-heavy tank, its silhouette a dark crown against the low cloud, its 75mm gun sweeping for targets. A Panther was every tanker's nightmare. It outranged and outgunned a Sherman. If the Rhino stalled while breaching, it could become a stationary target with the vulnerable belly exposed. Cullen's hands tightened on the rail. He had prepared the tank for this possibility. The angle of attack and momentum had to be perfect. Speed would be their armor. Hit it at a 20-degree angle. Cullen told the driver over the radio. Keep the nose down. Don't try to climb, bite through. They charged. The hedgerow rose like a wall of history, roots thick and intertwined with stone. Impact came in a violent bloom of mud and noise. For a breathless instant the Rhino creaked and shuddered as the prongs fought the living root matrix. Then momentum took them, the tusks tearing, the hull staying low, the Sherman's belly shielded by forward armor. As they burst through, Sergeant Harrison's gun found the Panther's flank. A single well-placed shot pierced the German tank's side armor. Its crew scrambled and fled. The Panther became a wrecked hulk in a field that minutes before had been a death trap for any advancing Sherman. That firefight, brief, chaotic, decisive, was the proof the skeptics had demanded. Word moved up the chain with the efficiency of rumor and the gravity of evidence. Lieutenant Atchison sent a terse radio message. Rhino proven in contact, bring welders. Within hours, welding squads were requisitioned, beached junk was hauled in, and sympathetic engineers sketched the angles Cullen had scrawled in his notebook. Field workshops sprouted in hedgerow clearings and abandoned barns. Men who had never held a torch learned, under Cullen's precise eye, how to cut the heavy steel hedgehogs into teeth, how to set a 15-degree downward rake, how to reinforce welds so they wouldn't snap like cheap wire. You want them low, Cullen would tell a flinching welder, chalking the spot on the tank's hull. Too high and you pop the belly. Too low and you just plow. 15 degrees, trust the angle. The modifications rippled outward. A platoon here, a company there. Every success created new converts. Within days the makeshift Rhino tanks began appearing across the front. The crude appearance of steel prongs jutting from Shermans was deceptive. What looked like an ugly add-on was a change in battlefield logic. Where commanders had once planned to skirt each hedge and trade small gains for heavy losses, they now had a tool to carve routes straight through the enemy's defensive geometry. It didn't take long for higher headquarters to take notice. Reports reached division, then corps. Major Williams's field report spoke plainly. The cutters increased breach success, reduced exposed vulnerabilities, and most crucially, allowed infantry to exploit created gaps quickly before defenders could reorganize. General Omar Bradley visited a field depot one afternoon and found Cullen down on his knees, guiding a reluctant welder's hand. Bradley listened, watched, and then simply said, "Show me the man who can produce 100 of these a day." He left a short while later with a grim, satisfied look in orders that stretched supply chains. Requisition steel, ship welders, and set up production lines in the field. Mass production in a war zone is a messy thing. Engineers made templates. Supply officers scrounged shipping manifests for spare steel. Beach salvage yards emptied. The dunes rapidly reduced from obstacles into raw material. Welding crews worked in 3-shift rotations, arc light strobing like lightning in a storm. Men sang off-key to keep from hearing the groans of metal under stress. The simple cutter moved from field expedient to doctrine by way of necessity, an invention honed in the pressure of live fire and then refined in the colder calculus of logistics. As the cutters spread, innovations followed. Tank crews, ever practical, adapted the design to their needs. Some added a 5th center prong to bite through especially broad hedge bases. Others serrated the leading edges to grab sodden roots instead of slipping. A clever crew in the 3rd Armored Division rigged a crude rake mechanism that would clear soil from the prongs as the tank moved. No longer did a cutter clog and require a stop for manual cleaning. Urban deployments revealed secondary benefits. Prongs shoved through brick and timber barricades, turning fortified farmhouses into mere entryways for infantry. Enemy reports, intercepted through signals intelligence and prisoner interrogations, showed a pattern of confusion. German dispatches spoke of American armor appearing where no armor should be. Tanks emerging from the earth itself, engines singing, guns already aimed. They tried countermeasures. Mines right at the base of hedgerows, shaped obstacles, decoy hedges wired to traps. None of these adjustments broke the Rhino's basic advantage. The physics of frontal armor and the element of surprise favored the cutter as long as crews adhered to the technique. Low, fast, and angled. The success carried human complexities. Commanders, seeing newfound mobility, sometimes pushed too hard. Columns that once waited for engineers to clear lanes began to rely on cutters for aggressive thrusts. Supply officers, faced with long lines of advancing armor, scrambled to keep fuel and ammunition moving at a pace that had not been planned. Convoys grew thin and stretched. In some sectors, the rapid advance created brief vulnerabilities as logistics caught up. Cullen found himself in heated talks with supply captains, arguing that victory depended on both the blade and the fuel behind it. His invention demanded not only steel and welders, but the systems to feed an army on the move. Kulin also found recognition uncomfortable. He wasn't comfortable with photographs or long-hand-written commendations. He preferred the smell of oil and the honest geometry of steel. Yet medals arrived. Promotions followed. Officers who had once shrugged at a corporal's suggestion now treated him with deference. He trained welding teams, traveled between depots, and watched as his crude idea became institutionalized. That institutionalization brought small logistics crises, occasional overuse, and, worst of all for him, moral weight. There were moments that lodged in his quiet hours. He remembered the faces of men who had died in tanks before the cutters arrived, the blackened hulls he'd studied on that first morning. He knew the cutters saved lives, fewer burnt crews, fewer trapped men, but he also knew they made killing more efficient. In the smoke of victory, in the joy of liberated towns, he wrestled with the cost. He'd made a tool that helped his side win, and winning meant others bled. A chaplain offered a simple thought during a late-night conversation. Saving lives and shortening war is a moral good, even if killing is its instrument. Kulin half accepted this and half resisted it. The ambivalence stayed with him like an old oil stain he could never quite wash out. Still, field reports were blunt. Where cutters led, momentum followed. Breaches multiplied, resistance thinned. By late July, as Allied forces pushed outward from Normandy, the cutter's role was unquestioned in many units. Factories adjusted too. Where early models had been welded in the field, production lines in the rear began shipping Shermans with factory-mounted attachment points, an official nod that an improvised fix had become standard equipment. The hedgerows that had once defined the battlefield had been physically and tactically subverted. As the armored columns streamed through the newly cut lanes, the war's tempo changed. Routes once blocked for days were cleared in hours. Supply lines, once a cautious ballet of engineers and infantry, had to learn a faster rhythm. The cutter's raw, genius simplicity had unlatched more than hedgerows. It had forced armies to rethink speed, supply, and the physics of offense in a countryside that had once seemed designed to stop them. By early 1945, the hedgerow cutters were so common that new crews treated them as if they had always existed. Tank manuals mentioned them without fanfare, just another piece of equipment among radios and spare track shoes. When something becomes invisible, it has succeeded completely. Kurt Kulin had achieved that kind of success. The Allied armies broke out of Normandy faster than even optimistic planners had predicted. Saint-Lô fell, then Avranches, then the open plains of France unfolded before the advancing armor. The Rhino Shermans, as soldiers called them, opened lanes for infantry, trucks, and artillery until the front resembled a moving tide. The same tanks that had once bogged down in hedges now thundered through villages and open fields, cutting paths not only through earth, but through the paralysis that had gripped the invasion. Kulin's name traveled with the machines. Reporters wrote about a sergeant inventor who gave our tanks teeth. General Bradley cited the cutter as a model of soldier ingenuity. When Kulin was summoned to headquarters, he expected reprimands about overproduction or safety reports. Instead, Bradley shook his hand and told him, "You unstuck my army." A legion of merit followed, then a promotion. He accepted them politely, almost shyly, and returned to the welding sheds where sparks and smoke still felt more honest than applause. He continued to refine the design. Some crews asked for detachable mounts, others for thicker reinforcement plates. Kulin listened, sketched, adjusted. He called it learning from the field, never improvement, because he insisted the credit belonged to every tanker who had bent the steel or driven the first tests under fire. His humility made him popular and slightly lonely at the same time. Generals wanted symbols, not collaborators. As the front pushed east, new uses emerged daily. In the towns of Belgium and the Netherlands, the prongs knocked holes in stone walls so infantry could pass from house to house under cover. In the snow of the Ardennes, they acted as plows, clearing drifts where wheeled vehicles would have sunk. During river crossings, they dug into muddy banks and held traction where unmodified tanks slipped backward. Reports even surfaced of Shermans using cutters to shove disabled enemy armor out of narrow roads, turning roadblocks into momentary obstacles. Every new application confirmed the same truth: the simplest ideas endure. Kulin, now wearing a technical sergeant's stripes, moved with an engineering evaluation team that documented these field improvisations. He carried notebooks filled with diagrams, corrections, and questions about metallurgy. He never stopped seeing himself as a mechanic. When younger officers tried to lecture him on physics, he smiled and said, "Engines and men, they both seize when you ignore friction. The war's final months were a blur of motion. Germany collapsed from the west and east like a structure whose supports had been cut away. On May 8, 1945, the guns went silent. Kulin stood beside his tank crews in a small German town and watched soldiers cheer, drink, and fall into exhausted silence. Around them the countryside was ruined and beautiful in equal measure. He thought of the first test field in Normandy, the hedge bursting open, the sudden light beyond, and realized that everything between that moment and this victory had unfolded because men refused to stop at a wall. Peace brought strange quiet. Kulin was sent home that autumn with medals, back pay, and a handshake from officers who promised to recommend him for post-war engineering posts. He declined most offers. He returned to New Jersey, reopened a small garage, and began fixing trucks again. Neighbors knew he was a veteran, but few knew what he had done. When customers mentioned the war, he nodded and said little. He found comfort in the steady rhythm of tools, the click of sockets, the hum of engines that could be repaired instead of destroyed. His wife asked once why he avoided talking about the invention that had made him famous. He answered quietly, "I built something that made killing easier. I'd rather build things that make moving easier." She understood. He carried the war in the creases of his hands, but preferred to speak through work. Historians rediscovered him decades later. Military schools cited the cutter as an example of field innovation. In lectures it became a neat case study. Problem, prototype, adoption. But behind that tidy diagram was fatigue, fear, and the stubborn will of a man who had refused to let mud dictate strategy. When an interviewer found him in the 1960s and asked what secret of genius had guided him, Kulin laughed. "There wasn't any secret," he said. "I just looked at a problem no one wanted to touch and touched it." He died quietly, leaving behind a handful of photographs, notebooks, and a generation of soldiers who rarely knew his name. The cutters, however, endured. In museums across America and Europe, old Shermans still display those crude steel tusks. They look primitive compared to the sleek tanks that came after, but the plaques beneath them tell the real story. This was the tool that broke the hedgerows and opened France. Visitors read the caption, "Designed by Sergeant Curtis Kulin, U.S. Army, 1944," and walk on, often without realizing they have just passed the evidence of how simplicity can shift the weight of history. His legacy lived not in the machines but in the lesson. Listen to the mechanic, the farmer, the soldier who sees a solution others overlook. War may have forged the cutter, but its principle belonged to every era. The belief that barriers are puzzles, not prisons. Long after Kulin's name faded from headlines, tank crews still welded prongs, blades, and plows to their vehicles in new wars, solving new versions of the same old problem. How to move forward through resistance. Each one, knowingly or not, echoed that long-ago mechanic who refused to accept that a wall of earth could stop a determined mind.